guys, we're going to look at graphing, okay? We're going to graph two functions. We're going to graph a square root function, and we're going to graph cube root functions. We're graphing roots, okay? So the first one that we're going to start with is the square root function. And guys, you know we always talk about the parent function, which is basically the most basic form of that function, right? So the square root parent function is this guy. F of x equals the square root of x, okay? So let's go to our calculators, because anytime we see f of x or y equals, let's go and graph it. Let's see what it looks like. So I'm going to go into my y equals, and I'm going to put in square root of x. Yeah, everyone doing this? Put this in your calculators, okay? And then let's graph it. Let's take a look. Does your graph look like mine? Yeah? Okay, so I like to call the square root function an eyebrow function. Because doesn't it look like an eyebrow? Yeah, right? All right, so let's see. Let's go to second graph. I see some decimals. I see some non-decimal nice integers. And what else do you see? Errors. Okay, where are the errors?
What? To the right?
At the negatives. Yeah, if you go to the left, right? The negatives. You know, why do you think so?
Because it's not negative.
Okay, it's not. You know, at 0, it gave me 0, right? Because if basically any number that you put in for x, are we plugging it in to our original equation? So what happens if I put a negative inside the square root? You get what? Yes, imaginary numbers. And imaginary, are they real? No, right? So you can't graph the imaginary numbers. So square roots, not going to have negative. All right, so let's go and get the points that are non-decimals, that are nice and pretty to graph. So we have 0, 0, we have 1, 1, we have 4, 2. Anything else after that?
Like a decimal.
Okay, well then scroll down. See if there are any more. See if there's one more. And 9, 3. Yeah? Which makes sense, because what is the square root of 1? What's the square root of 4? What's the square root of 9? 3. Okay, so whatever number you put in for x is giving us the square root, right? All right, so let's go graph this. So I'm going to go to 0, 0, 1, 1, 4, 2, and 9, 3. There we go. Okay. Couple things. The square root graph is always going to be going to the right, because it's always going to be going towards infinity. All right, we're not going to the negatives. Your starting point is basically your first number after all those errors, right? What is it? What is your starting point? Where does this graph start?
0, 0.
0, 0. Now, let's talk about the domain. Remember, guys, the domain is looking at the graph from the left to the right. What x number does this graph start at?
0.
0. And then it's going to infinity. Good. Starting at 0, going to infinity. And there's a closed dot at 0, so please remember to put a bracket at that 0 for your domain. All right, so let's talk about the range. Okay. Remember, that's looking at the graph from the bottom to the top. Where does this graph start on the y-axis?
0,
0. And it goes to infinity. Because this arrow, well, first of all, it's above the starting point, right? And this is slowly going to go all the way up to infinity. Does that make sense, Sabrina? Okay. So this one also goes from 0 to infinity. What is my y-intercept here, guys? Good. This graph crosses the y-axis right at 0, 0. And you know, the nice thing is with parent functions, a lot of things happen at 0, 0, don't they? Yeah. So then how about the zeros? Are there any zeros?
0, 0.
Yeah. And remember, the other word for zeros is x-intercepts. Yes, thank you. So this graph also crosses through the x-intercept at 0, 0. It just touches. Okay, so a couple words, all right, about the next one. Increasing and decreasing intervals. A couple things I would like you guys to write down. You can only have one. You can't have both. That means it can only be increasing the whole way, or it can only be decreasing the whole way. There are no turns on this, right? You don't see any turning points. So you don't have multiple intervals where it increases or decreases, okay? Only one, not both. And remember, these intervals always use parentheses, no brackets here, guys. And remember, we're looking at the x values, right? So let's see. Let's look at this. My graph starts at right here at 0, 0. The x number that this crosses through is 0, isn't it? Or that it starts at. And then this is going to what? Infinity. What is this graph doing from the left to the right? Good. It's increasing. Good. So this one for the parent function is increasing from 0 to infinity. You know what? I'm also going to put this here. This interval should be the same as your domain. With this one is nice because it's going to be the same as your domain. So you have to make sure you get your domain right. So if the whole graph is increasing, well then that means my decreasing is none. Right? Can't have both. And then let's look at the right end behavior. For these, you only have one arrow. That means you only have one right arm that's doing something. Here, what is this right arm doing? Is it going up or down? Up. And we know that it's going up to infinity because it's above the starting point. Okay? Up to infinity. There we go. That's it. Is that pretty good? All right. Amner, you feel good about that? Okay. You guys ready for the cube root? Okay. All right, so then let's look at the cube root parent function. So the parent function here, the most basic way, is f of x equals the cube root of x. All right, so let's go and graph this. Go to y equals, where is cube root? Good. Math, and then it's the fourth one down. Cube root of x. Tom, do this, do this. Focus, are you with us?
It's like negative.
Huh?
It's like a snake. It goes like that.
Super, yes. You know what? And that's what I call it. I call this one the snake. Kind of looks like a snake, right? Maybe those like things, you know, when you have a ribbon on the stick, they look like this.
Yeah.
All right, so this is what your graph should look like. Yeah? Let's go to second graph. And let's look at our points here, okay? So guys, the thing I want to tell you about these cube root functions is you need to look for the cluster. Cluster of 3 points that are nice, easy to graph points. You're going to have 1, 2, 3, okay? So you see how my cluster here is at -1, -1, 0, 0, and 1, 1? The one in the middle of that cluster, that is your center point. Does that make sense? Okay, so let's go write down our cluster. And then I left the space above and below because I know there's got to be another pretty point above that cluster and another pretty point below that cluster in my table. Can anyone find that for me, please? So we have an 8, 2, and then? Good, -8 and -2. You know how I knew that? Because you can take these x numbers and plug it in to get your y, right? What is the cube root of -8? -2, right? Cube root of -1, -1. You see? Okay, and that's what you're doing. You're choosing numbers that you can put it into the x value to get the y's. All right? Okay, so let's graph this. -8, -2. All right, put all your dots there, and then we can connect them. Make it look like a snake. And it doesn't have to be perfect, but try to get it as neat as you can, please. What did I say the center point is again? 0, 0. Because here's my cluster of 3, right? And the one in the middle is the center point. My center point is at 0, 0. Okay. So guys, let's talk about the domain.
Negative infinity to infinity.
Oh my goodness, good. How did you know?
Because the arrow on the left side. Arrow on the left side.
Super. There's an arrow on the left side, arrow on the right side. Domain is negative infinity to infinity. Excellent. Excellent. Thank you. Does anyone want to try the range? Same thing. Oh my goodness, you guys are just killing it. Yes. Same thing for the range because look, here's the center point. Look, you have an arrow below it. So that means it's eventually going down to negative infinity, right? You have an arrow above, so it means that's going to go up to positive infinity. Your range is also negative infinity to infinity. And you know what, guys? Put a star on this, because no matter what transformations this guy goes through, is always the case. Domain and range for your cube root functions is always all real numbers. Okay? So what is my y-intercept here?
Your intercept would be 0, 0.
Yeah, 0, 0. It crosses through the y-axis at 0, 0. Does this cross through the x-axis anywhere? Yeah, 0, 0. Thank you. Now, for the increasing and decreasing intervals, guys, same thing. You can only have one, not both. I should write just one. I should probably say only one, right? Only one, not both. And again, this is going to be the same as the domain, so it's going to be negative infinity to infinity, right? Look at this graph from the left to the right. What's this doing?
Going up.
Good. Going up. It's increasing. Good. So it's increasing from negative infinity to infinity. And generally, your right end behavior kind of tells you what it's going to do. If your right side is going up, well, then it only makes sense that it would be increasing, right? If your right side was going down, well, then be decreasing, right? For these, anyway. So, none here. It's increasing, it's not decreasing anywhere. So tell me, what is the left end behavior doing? What's the left arm doing?
Negative.
Going to negative. Good, it's going down. Good job. So then what's the right arm doing? Going to infinity. It's going up. Good. All right. How do we feel about that? Okay, good. All right. So, of course, we can't talk about functions and not talk about transformations, right? We love transformations. However, you know what? I don't really love doing the same thing every single time with the transformations, right? That's pretty boring. So, what we're going to do is, I gave you the transformations, and I was thinking we could do it backwards. You can tell me what it's supposed to look like in order to do that transformation, all right? So what I did here was, I put both forms. I put the square root form and the cube root form, because it doesn't matter. It's all going to do the same thing, right? So let's start with our A's. A is a number, or A is a thing in the front, right? If I want to show that it reflects or it flips, what would my A have to be? Good, say louder. Negative. Yeah, it reflects or it flips if there's a negative in the front. How would I know if it stretches?
It's the opposite. Like, so,
What kind of a number would have to be in the front?
negative or positive.
Small number, a bigger number. Bigger than 1. Yep. The number in front here, if it's a number greater than 1, so A greater than 1, that's what we usually write. Yeah?
Yeah.
But if that actually doesn't make a whole lot of sense to you and you have a hard time remembering it, just write it in your own words over here. You could say greater than 1. You could say bigger than 1. You can put some examples. All right? Do what you want to do. Use your own notes to kind of help you, because that's not going to change. So then how do I know if it compresses? Less than 1, but still bigger than what? 0. So it has to be, so the technical math way would be this, but you would say between 0 and 1. Right? You have a number there that's between 0 and 1, so like say 1/2, for example. That would be a compression. All right, let's go to something a little bit more fun. H. So the H is the guy that's always with the X. Inside whatever it is that we're talking about. Parentheses, the radical, absolute value bars, whatever, right? So that always tells me if it goes left or right. So tell me in terms of like with X, which one tells me left? X plus H or X minus H?
Plus H.
Good, yeah. X plus H, good job. Perfect. So then right has to be what? Yeah, X minus H. Excellent job, guys. So this last one, you guys all have to get this one, right? The K. Well, the K that's on the outside, right? Far right, usually. That tells me up or down. So which one's up? Yeah, plus K. So what is down? Yeah, minus K. Good. I would cry, like literally cry, if you guys were like, right on there. But it's okay. Listen, if you didn't remember this, all right, then just please make sure to be more conscientious about which parts of the homework and the notes you need to, kind of pay more attention to. All right. All right. So let's look at the next one. How did this graph move from the parent function? That means you're starting from a basic square root of x. What kind of stuff got added on here? Yeah, these 3 things. How did they move? Tell me the transformations. How did they change the graph? First off, that plus 2 on the outside, what did that tell me? Up 2. Okay. Now what about with the x? The x minus 3.
Right minus 3.
Good, right 3. And then what about that negative in the front? Flips or reflects? Good. Now I'm totally okay with you guys writing flips, but I'm going to write reflects. So now I want you guys to try the next one, please, and then we'll check together. All right, so thank you, Timlin. So it stretches by a factor of 5, which is stretches, and left 1 and down 3. Super. Okay? All right, so let's go on to the next examples. Oh, although, you know what? Before we try these examples, no, you know what? No, let's do that. I'm sorry. Yeah, let's do this. I like this. Sorry. So, all right. Number 1, f of x equals 2 root x plus 2. Okay, let's put this into the calculator and let's see. So please be careful. You have a 2 in the front, so put the 2. Then then you have the square root of x, right? Is there anything else inside the radical? Number one. Number one. No, so you gotta close it, and then plus 2, right? If you don't close the parentheses there, you're saying the plus 2 is inside the radical with the x. All right? Hit graph, and your graph should look like this.
Looks like number 1.
Looks like what?
Number 1.
Oh, you mean the first one that we did? Yeah. All right. So tell me, guys, what is my starting point here?
0, and then a negative 2.
What?
Positive 2.
0, 2. Everyone get that? Do we agree? Okay. So I'm going to draw a little table over here for myself. 0, 2. What is the next point that I can use? Huh?
1, 4.
1, 4. Thank you. And then?
4, 6.
4, 6. And I feel like there's one more. 9, 8. Okay, let's graph those. All right, so starting point is at 0, 2. And then, guys, I want you to write down the transformations. What kind of transformations happen here?
Stretches 2.
Uh-huh. Stretches and?
Up 2.
Good. Super. Now, take a few seconds and try the domain and the range. When you do the domain, you can, also use your pencil. Run your pencil left to right. See where the graph starts. So where does this graph start? What x number?
2.
0, all the way to what?
Infinity.
Okay, so the domain for this guy is 0 to infinity. 0 with a bracket because there's a closed circle there, right? And what would my range be?
2 to infinity.
2 to infinity. Excellent. Yes. Oh. 2 to infinity. Great. And 2 gets a bracket as well. Closed circle, right? Now, what is the y-intercept here? 0, 2. Excellent. And tell me something. Do we have any zeros? Do we have any x-intercepts? No, it doesn't actually go near this x-intercept at all. So no real solutions, right? So we'll say no real. Okay? Because I'm sure if we solve this, get an imaginary. So now, which one is it? Is it increasing or is it decreasing?
Increasing.
It's increasing. From where to where?
From 2 to infinity.
Good. Careful. From 0 to infinity, not 2. Because if you say 2, you're saying the graph is starting here.
Oh.
Okay? Remember, because it's the x's. So it's from 0 to infinity. And remember, it's going to be the same as your domain. So it's increasing from 0 to infinity. So if we have an increasing interval, it means we have no decreasing interval. And where's my right end behavior going?
Infinity.
Infinity. Great. Guys, excellent. Excellent. You're doing such a great job. All right. So then let's try a cube root function. Okay? Now let's put this, you know what, before we put in the calculator, can we talk about the transformations? Yeah, let's do that. What transformations happen here?
Stretches to 2.
Okay, stretches. Sabrina, you want to tell us one? Okay, up 3, thank you. Cindy, you're quiet. What else does it do? Left one, yes, okay. Now graph this and let's get our center point. In the calculator, right? So we have 2 math 4 x, what's inside the radical with the x? This one? X plus 1. And then plus 3. Okay. You see how I close my parentheses after the 1? Because that is where my radical stopped, right? So when I go to graph this, let's take a look. It better look like a snake because it's a cube root, right? Okay, there it goes.
Why are those things so slow compared to the other ones?
I don't know. Just takes a little bit longer to think, I guess. All right. Let's,
Is that break on purpose, or is it just because?
no, sometimes it just, yeah, sometimes it just does that. So, do you see the cluster? Cluster, right? The 3 points?
Then there's only 7 of them.
Yeah. Well, you gotta find your cluster, and the one in the middle is the center. Yes? Okay, so let's write down my little table somewhere. I'll put it over here. X, Y. Okay. Will you give me the cluster, please? What are the points? -2, 1. 0, 5, and?
7, 7.
Okay, so 7, 7. Where's the third one? -1, 3. -1, 3. Yeah? And what's above -2, 1? Because I'm assuming that this is my cluster right here, right? That's my center point. Yes, Timon?
Yeah.
What is I know there has to be a point above the -2, 1. -9. -9, -1. Thank you. So for the center point, I'm going to say -1, 3. And let's graph this. Oh no, -2, 1. Excuse me. So something like this, right? Here's my center point right there. Okay? Do we have the same graph? Okay. What's the domain and the range? Always. Guess what? Yeah. Yeah, -, infinity to infinity, all real numbers. That is your range. And your domain. Any questions so far? Are we doing okay?
Yeah.
Alright. Somebody tell me the y-intercept. Where does this graph cross through the y-axis? Huh? 0, 5. And you know what? Is there an x-intercept? Yes, there is. But it's not at a good point, is it? Alright, so since there is one, but it's not at a really good point, I mean, we still have to find it. And you guys know how to find it. Phoebe. Blinking Bob. Blinking Bob, right? Alright, so go back to your graph. I want everyone to try this. Cindy, try this with us, okay? So go to graph and then hit second trace. And then go to the second option here where it says 0. Hit enter. Now, you want to move Blinking Bob all the way down to that x-intercept. Right there. That's your starting point, okay? And your calculator's saying left. So go to the left. Let's hit it like 4 times. 1, 2, 3, 4. Yeah? Yeah?
I need some graph. I can't find it. I don't know how to get to the link.
Oh, can't see Blinking Bob? Second.
What is
0. Okay, now move it to. All right. And then go back to where you started at. And then now it's saying, wait a second, hold on. Did I hit enter? Did I not hit enter? I didn't hit enter. Excuse me. And then go back to your starting point. Now your calculator's saying hit the right arrow. So right arrow, 1, 2, 3, 4, 4, 5, doesn't matter. Hit enter. Hit enter again. Okay, so Tom said, oh, decimal. Did you get this decimal? Good, that's okay. You can get a decimal. Just make sure that your y number is 0, because then that is your x-intercept. All right? So for the zeros, let's see, negative 4.375, comma, 0. Good. All right, so now, is this increasing or is it decreasing? Yeah, it's increasing. Are you going to say that, Adam? Why? So then where is it increasing? From where to where? Yeah. Negative infinity to infinity, all real numbers. So then it's decreasing at none, because you can't have both. You can only have one. So what is my left end behavior doing? You're going up or down? What's my left arm doing?
Going
Down to negative infinity. How about the right?
going up. Okay.
Good job. All right, so before we try these other ones, you know what? I want you to go to these problems on the back, please. Back of this page. I want to try problems 7 and 8. Huh?
Never mind.
What'd you say?
I was gonna say, why are they the same kind of thing as 3 and 4?
Okay, well, how are these different?
Well, the difference is there's transformations.
Yeah. And I gave you the graph, right? So you may have a problem like this on the test where I give you the graph and I want you to write the equation. So here's another tip for you though. On the test or on any test, okay, if you get a multiple choice problem and they give you the answer choices, right? Couldn't you plug in each of them and see if it looks like your graph? Yeah. But this one, can we do that? No. Okay, so we're actually gonna write it out. But that's something else you could do. So this one is gonna be a square root, number 7, because it's an eyebrow, right? And for the square root function, guys, where was the starting point for my parent function? Where did it start? Well, this one does, but the original one, the one that we first looked at, the most basic.
0.
Yeah, it started at 0, 0, right? So tell me how this graph went from this to that one, to the blue. How did it move? It went up how many? You know what? I'm gonna move this one out of the way. 4. 1, 2, 3, 4.
Yeah.
Okay, so up 4, and then. Oh no! Did it go up 4?
No, I went up 3.
Oh no! We went up too much. It went up 3, and then left 2. Good. Okay. So then now, what is the equation? Well, y equals square root x. How do I put left 2? Plus 2.
Yeah.
And then up 3 is on the outside, right? Plus 3. So there I go. That's it.
Did you put the cube?
Nope, because the cube one would be the snake one.
Oh,
Alright, then let's look at number 8. And guys, this statement right here, assuming the absolute value of A equals 1, that means that there are no stretches and no compressions here. Okay, so don't worry about stretching or compressing. The only thing you should worry about is, did it flip? Okay. And if you are unsure if you did this right, couldn't you put this equation into your y equals and make sure that it looks like your graph? Yeah. All right. And that one is right. So let's look at number 8. So number 8, where is that center point for this blue graph? Where is the center point? That one's not the center because it's not like right in the middle of that curve.
it should be around. Yeah.
1, 3 is this guy right here. I mean, right there. Yeah? But good. I'm glad you said that one out loud because that's where most students think it is. Okay? The center point of my parent function was where? 0, 0. You know, it's usually a 0, 0, right?
So it went up 3 and then it went to the right.
Okay, so it went right 1 and what?
Up 3.
Okay.
I think so. Yeah.
Right 1, up 3. Does it look a little different to you?
Yeah.
The whole snake itself?
Looks like it's upside down.
Yeah, the snake looks like it's upside down. Why? Because it flipped. And you can tell because the right arm is now going down. So it also reflects. Does that make sense? In the parent function, the right arm was going up.
So it's y equals.
Okay? Y equals
Negative cube root.
negative cube root.
Oops, not sure. Cube root. And then minus 1.
X minus 1. Uh-huh.
And then
Plus 3.
plus
Yeah.
3.
Yeah, good. Super. Good job. So, okay, you know what? If you can, let's do number 4. Yeah, let's do number 4. So, I want you guys to try number 4. Give me the starting point, give me the domain and the range, and graph it. Okay? This one was a tricky one. Alright, so, but I thought, you know what? I thought you guys could get it, and you were very close. So, I'm so glad that you guys tried this. Your graph, first of all, your starting point is at -3, 0. Yes? Right?
Yeah.
Your graph looks like that.
Yeah.
The reason why the range felt so weird to you guys is because of this. Your graph is flipped. Yeah?
Mhm.
Well, it's okay if your graph is flipped because look, here's your starting point, right? And your graph goes below that. Well, where's that graph going?
Oh, then negative.
To negative infinity. And you remember, negative infinity is always on the left. Okay, it's never on the right. So it's basically you're starting from negative infinity, and then this graph goes all the way to what? 0. So you had the right numbers, you just didn't have it in the right order, which is, that's better than not knowing at all, right? Just remember the order. You always go from the bottom to the top. Yeah?
Yeah.
Okay. Well, I think you guys did a great job. Next class, we're going to do the review for the test. Okay? You guys do have a graphing homework for tonight, homework F, and I really need you guys to do this. Do not come unprepared. All right?